So in this first problem, we read a force of 40 newtons accelerates a 5 kilogram block at 6 meters per second squared along a horizontal surface. So just as a reminder, this is problem 71 on page 145. Alright, so let's take a look. Let's get an understanding as to what we're seeing here. So as it mentioned, there's a force that's being applied on this block, and that force is 40 newtons. So the first part of this question is asking what would the block's acceleration be if the surface were frictionless? So the block is being pushed, or there's a force that's being applied to it of 40 newtons, and it's moving along a horizontal axis, and it's accelerating at 6 meters per second squared. So something to consider, when you look at A, it says what would the block's acceleration be if there was no friction? That means that there is a friction force working in the opposite direction. So if you can imagine pushing a crate on a horizontal surface, it's going to push back. There is going to be some pushback, and that's going to come in the form of friction. So because there's a frictional force, we need to figure out how much friction, how much kinetic friction there is, how much force is pushing back against our applied force. And then that will let us know how much faster this crate would move otherwise. So I want to figure out an equation to use. So I know because there's multiple forces at work here, there's going to be a net force. Well, I need to consider what are the forces at work that would, all of them that would add up to be that net force. So I would have mass times acceleration. Now, how would I know to use mass times acceleration? Well, if I read the problem, it gives me a mass and it also gives me an acceleration, so I know that that part of the force equation is going to be necessary here, and that's just your standard Newton's second laws of F equals ma. So you know it's going to be used to some degree here. Now, also something else to consider is your force applied. So for this part of the equation, I'm considering all the things that are happening in my problem. I have a force that's being applied to a crate, and I need to subtract the frictional force that's working against that crate. So if you go back to the image I had earlier, I have a vector arrow pointing in the direction of the applied force, and then I have another vector arrow that's pointed in the opposite direction that's working against my applied force. So when I add those two forces together, that will give me my net force, which also equals mass times acceleration. So it's very important that you see the relationship between these three components in my equation. So now that I have everything at work here, I need to carefully consider what parts do I need and what parts do I not need. Now again, because my problem has a force or has a mass and an acceleration, I know that the middle aspect of my equation will be necessary, and because I'm working with an applied force minus a frictional force, I know that my third part also will be necessary. So that means force net, I can go ahead and just take that off. I'm not going to need that. So because of the force applied working against the frictional force, I know that my third component I will be using, as well as my mass times acceleration. Okay, so I can take off the force net, and let me just clean up my equation. So let me back up a little bit. Recall that my problem is asking how fast the crate would be moving without friction, and I need to figure out how much frictional force I have. So that means in this equation here, the term that I am looking for is my F of sub F, my frictional force. So just like any other algebraic problem, I want to isolate that variable, F of sub F. So to do so, I'm going to subtract my mass times acceleration and move it over to my right side, giving me this new equation. Now, of course, as you know, there are many ways that you can work this out. This is just one way. The point is that I want to isolate F sub F because that's the one that I want. So now I'm going to remove my F sub F, and as you can see, by doing that, I have now isolated my frictional force. So frictional force equals force applied minus mass times acceleration. And that's what I'm working with now. And now I can look back at my problem. Okay, I can look back at number 71, and I can see all the givens that are given to me in the problem. I know my applied force, which is 40 newtons. I know my mass, 5 kilograms, and my acceleration, 6 meters per second squared. And so at this point, because I've structured my formula in the most practical way in terms of what the problem is asking for, now all I got to do is just plug and chug. Plug in my values for my variables and do the algebra. And there you go. Okay, so I'm doing 40 newtons minus 5 times 6, which is 40 newtons minus 30 newtons gives me 10 Newton force. Now I've just figured out something very key to the problem. I have figured out the amount of force that is working in the opposite direction of my applied. So I take you back to the problem of what would the block's acceleration be if there was no friction. And now I know that friction force, which is 10 newtons. So the block with friction goes at an acceleration of 6 meters per second. Okay? And now that I know that friction force, I want to remove that friction force and see how fast would this block go without friction. So I'm going to go back to my original problem because part A is asking for the acceleration of the crate without friction. So I use this one because I have acceleration and also I still have my force applied minus my force, my frictional force. So recall that I have an applied force of 40 newtons. And then I have a frictional force that's opposing that motion, and I want to know how fast it's going without that frictional force. So this is the equation that I'm going to use, and of course, like I mentioned before, I don't want to have friction a part of this equation. So my equation is going to change a little bit because it's mass times acceleration equals force applied minus frictional force, but of course I don't want frictional force. I want to see how fast it goes without that opposing force. Okay, so recall I'm looking for acceleration, so I want to isolate that variable by dividing by m on both sides, and I end up with a new equation, force applied divided by mass. So 40 newtons divided by 5 kilograms, that is 8 meters per second squared. So this is the acceleration of the crate without the opposing frictional force. So as I look at both problems and how they worked out, I have the top illustrating the acceleration of the crate with friction, and then at the bottom I have the acceleration of the crate at 8 meters per second squared without friction. So as you can see, without the opposing friction, I have 2 meters per second in acceleration. So I'd like to finish up this problem by showing you how to find the coefficient of friction. So part A asks for the acceleration of the crate without friction. Now we're going to look for the actual coefficient of friction. So we're pushing the crate. So we're going to find out how much exact force is between the two surfaces of the crate and the horizontal surface. So frictional force, if you recall from your book, the formula is mu times the normal force, which is the mass times the gravity of the object, right? So this is my equation, frictional force equals mu times mass times gravity. And again, I want to isolate my mu, which is my coefficient of friction. So I'll do that by dividing both sides by mass times gravity. And this is my new equation now. So having everything in place, I look at my problem and I look at my givens. My frictional force, which I found earlier, and my mass, 5 kilograms, and then gravity is a constant, 9.8 meters per second squared. So now having all of my the values for the variables in place, I can now exchange my variables for the actual value, and then just do the algebra. Plug in my numbers, plug and chug, and get to work on the math. And I find that the coefficient of friction between the crate and the horizontal surface is 0.2. Okay, and because this is actually it says static friction, it should say kinetic friction. In fact, let me change that real quick. There we go, much better. Kinetic friction. It's kinetic friction because the object is in motion. This is the friction that's opposing the object in motion, as opposed to static friction, which is opposing the object as it's not where there is no motion. So this is a summary of 71 The top, I have the illustration of the object being moved with the applied force of 40 newtons, with the opposing frictional force of a zero point 0.2 coefficient of kinetic friction, and of course that's multiplied by mass times gravity, and that came out to be 10 newtons. And so with that opposing force, the person was able to move the crate at 6 meters per second squared. Now at the bottom, we had the same applied force of 40 newtons, but this time you had no friction. And the acceleration of the crate in that situation is 8 meters per second squared, which makes perfect sense because if there's no friction, there's no opposing force, then you should be able to accelerate it at an increased rate. Okay, I hope this helped. This was number 71 in your review problems. Good luck in your study.